In this video, we're going to be looking at piecewise functions, and here's an example of a piecewise function in a real-world situation. A t-shirt company prices their t-shirts as follows: $12 per shirt if you order less than 100 shirts, $10 per shirt if you order 100 or more. And that's written out verbally. That's easy to understand. We see that type of thing all the time. And in the next part of my problem here, you see this written out algebraically, where you've got your function defined in two different ways depending on what your x value is. So the first question I have here is, how much does 20 t-shirts cost? Well, we need to figure out which part of these functions do I need. Do I need to do it 12 times x or 10 times x? And again, going back to what I have written up here, if I order less than 100 shirts, they're going to cost me $12 per shirt. So I'm going to need to put replace x with 20 using this first part of my piecewise function. So there you can see my answer is $240. The next question is, how much does 300 t-shirts cost? Well, with 300 t-shirts, I'm more than 100, so I'm going to be using this formula right here, 10 times x. And there I can see my answer is $3,000. Okay, here's an example of a piecewise function that is defined on two different ways depending on whether my x value is less than -2 or greater than or equal to -2. So what I'm going to start off doing by making a number line with -2 as the key point on my number line. Now this first part of my piecewise function says that if I am less than -2, if x is less than -2, I'm going to be using this expression here to evaluate my function, 2x plus 4. If I am greater than -2, I'm going to be using this expression, -3x minus 3. And if I am right smack dab on -2, according to this inequality where it says greater than or equal to, I'm using this expression of -3x minus 3. So if I'm right at -2, I'm going to be using this expression over here toward the right. Now, the first problem, I'm asked to find f of -5. Well, on my number line, -5 is over here to the left of -2. So I'm going to be using this expression of 2x plus 4. So that's going to give me -6 for my answer. To find f of -2, I'm going to be using this expression over here toward the right of -3x minus 3. So I get 3 for the answer. And the last problem here is asking me to find f of 3, so again I'm going to be using this expression to the right. And I get -12 for the answer. I want to mention one thing about the number line that I have. You don't need to make a number line when you're working through this, but I think that it helps because I think a visual always helps. You may not need to write out this number line, but that needs to be your thinking when you're going through this problem. Here's another example of a piecewise function. I find this interesting because when you look at this expression here toward the right of the equal sign, I do not have an x in my expression. And it may seem kind of odd, like how do you have a function when you trying to say x is less than 12 or greater than 12 and you have nowhere to put your x in? Well, I think this type of problem actually is one that you see quite a bit in the real world, and you don't necessarily realize that it could be written as a piecewise function. So let's pretend that you have a carnival that you're going to, and the carnival charges $9 for adults and then $5 for children 12 or under. This is an example of how you would write this algebraically, right? If you're 12 or less, you're going to be charged $5. If you're more than 12, you're going to be charged $9. So I'm going to do this problem similar to I did the previous one. So here you can see, if I want to find f of 2, that's asking me how much does it cost for a child who is 2. Well, that's less than 12, so the cost is only going to be $5. If you're exactly 12 years old, it's going to cost $5. And if you're 14, it's going to cost you $9.